6.1, absorbing and losing heat. Heat absorption. So we know that materials absorb heat at different rates, depending on what the material is made out of. This can be really useful depending on what you'd like to accomplish with a substance. So for instance, when we make a pot for cooking on the stove, we use metal because metal conducts energy or transfers energy at a very fast rate, whereas we put plastic or silicone or something on the ends of the handles because it doesn't absorb heat very well. Different substances take different amounts of heat to raise their temperature the same amount. Each substance is unique. We can measure this by the specific heat capacity. It's a measure of a substance's ability to absorb or lose heat. So the unit is joules per gram, sorry, that should be a little g, degrees Celsius. Okay, so this says something will take some number of joules to raise 1 gram of that substance 1 degree Celsius. Because there's no numbers in front of these, we could assume that they are ones. Okay, so the number is the number of joules, and the joules is a measure of energy. Okay, so it's how much energy it absorbs per gram of that substance to change 1 degree Celsius. For instance, let's take a look at water. So water has a specific heat capacity of 4.19 joules per gram degrees Celsius. This is just like a little multiplier to show that these are two separate units. So this says that it takes 4.19 joules to heat 1 gram of water by 1 degree Celsius. So that's the same if I'm heating water. Again, it has to be water, not ice, from 7 to 8 degrees Celsius or 89 to 90 degrees Celsius. It doesn't matter how warm that water is. It will still take 4.19 joules to heat 1 gram of water, either of these temperature changes. Okay, so let's compare the specific heat capacities of water and sand. What can you learn from the values? So water was 4.19 joules per gram degree Celsius. And sand has a specific heat capacity of 0.66 joules per gram degree Celsius. This means that it takes, let's compare like the same temperature changes. Let's say from 7 to 8 degrees, 1 gram of sand takes 0.66 joules of energy to heat, whereas from 7 to 8 degrees Celsius, 1 gram of water took 4.19 joules to heat. So it takes less energy to heat sand. Energy to heat same amount of sand. So on a hot day at the beach, would you rather stand in the sand or the water barefoot? So on the hot day, the sun is beating down on the water and our sand. The sun is giving off the same amount of energy to the water and to the sand. It takes 4.19 joules to heat 1 gram of water, and it only takes 0.66 joules to heat 1 gram of sand. So the sand is able to heat up more than the water. So the sand will warm up more than water because it has a lower specific heat capacity. So if it's going to heat up more, it's going to be really hot to stand on. Therefore, I probably would prefer to stand in the water. In water, not so hot. All right. Let's do one more example here. How much energy will it take? Let's say, how much energy will it take to heat? Let's say 2 grams of copper at 2 degrees Celsius. All right. So copper has a specific heat capacity of 0.38 joules per 1 gram, 1 degree Celsius. So to heat 2 grams, I'm going to need to double this. All right. So that gives me 0.38 times 2 is 0.76 joules, and that is to heat 1 degree Celsius. However, we want to heat by 2 degrees Celsius. Therefore, I'm going to multiply this number by 2 as well. And I'm going to get that it'll take 1.52 joules to heat 2 grams of copper by 2 degrees Celsius. So I simply multiplied my specific heat capacity by the mass and by the change in temperature. So the change in temperature that I was looking for. And that will give me how much energy it takes to heat that substance. Remember, oceans moderate shore area temperature. We learned about that in chapter 5. Water has a high specific heat capacity and stores more thermal energy than you think. Water's large specific heat capacity allows it to absorb, store, or release much more thermal energy than land, without decreasing its own temperature very much in the process. Again, let's think of sand and water. Water had a specific heat capacity of 4.19 joules per gram degrees Celsius, and sand, I think, was 0.66 joules per gram degrees Celsius. So, when water gives off or reduces its temperature by 1 degree Celsius. So when water cools by 1 degree Celsius, it releases 4.19 joules of energy. Sorry, that should be 1 gram of water. When 1 gram of sand cools by 1 degree Celsius, it releases 0.66. Now, we know that because sand has a lower specific heat capacity, it's more likely to give off more energy. So when water cools by 1 degree Celsius, we get lots of energy. To get the same amount of energy out of sand, we either have to cool lots more of it or we have to cool it by more degrees. Okay, so because water can release so much energy in comparison to everything else and only lower its temperature by 1 degree Celsius, water is a great storage unit for energy because it doesn't go up by very many degrees Celsius to store lots of energy. Again, think 1 gram of water is very small, maybe a few drops of water, okay? 1 milliliter actually. So an ocean has such a massive amount or mass of water. To cool it by 1 degree Celsius or to heat it by 1 degree Celsius takes a massive amount of energy. So it can store lots. On a hot day, water absorbs heat, slowing down the rise of temperatures in the area. Okay, because it takes the heat out of the air, stores it in its molecules, and it doesn't raise its temperature very much. At night, water releases some of that heat, slowing the cooling in the surrounding area because, of course, the air temperature is cooling off, but the water starts releasing its energy that it stored during the day, and it raises that air temperature just a little bit. Take a look at the practice questions on page 110 of your Science Connect 1 textbook to review some of these ideas.